lecture is about water. And you know, I'm a marine biologist, a marine coral reef ecologist. So water, fresh water, is really not my specialty, but I have inherited this presentation from the previous wonderful professor, who, Dr. Bob Kinsey, who taught this course from zoology before me, and also from Dr. A.L. Dewart, who contributed to Dr. Kinsey's lecture, and Dr. Dewart is now with Bishop Estates, Kamehameha Schools, Bishop Estates, as their water manager. So there's lots to talk about. Hydrology, hydro, is the study of water. The Hawaiian word for fresh water is wai. What is the Hawaiian word for salt water? Kai, thank you. And you see the important influence of water in the Hawaiian language, Hawaiian culture, English language, English culture. So let me just introduce you to some words. Clouds, ow. Luawai, wai is the water. Lua is a pit. So that luawai is a hole of water in caves, a hole with water in it. Wai kai, interesting word, right? Fresh and salt mixed together. That's brackish water. Punawai, like puna hole. Punawai is water from springs. Kahawai is a stream itself, a river. Muliwai is the stream mouth when it backs up to the shore. So a couple of examples that you might know of on this island. You know where Buzzes is in Kailua? Or the boat ramp? So the stream from Enchanted Lakes comes down and backs up against the sandbank. Behind the sandbank toward shore is the Muliwai. At Pounders in Laie, the stream comes down and backs up into the sand berm, and every so often breaks through to the ocean. But before it does, it makes an impoundment of water, of fresh water, and that's a Muliwai. Wailele, isn't that a great word? The waterfall. Waihi. If you drive over the Pali, like I do every day, you look down when you're stuck in traffic on the side of the mountain and you see water trickling down out of the rock. Waihi. So why is so important? Because what is the first thing, if you run out of, you're going to die. What is the first thing?
Water?
No, oxygen.
Oh.
Right? If you don't have air, oxygen, you're going to die. The next thing that you're going to run out of, if you're deprived, would be water. And the next thing after that? Nutrients, that's right. So air, water, and food. Why is very important. Why in the Hawaiian culture is represented by, I think best by this term, vai, is wealth. That means lots and lots of water. If you have lots and lots of water, you're a wealthy individual or community. So Hawaiians understood, surrounded by salt water, which you cannot drink, right? That the value of fresh water was very important. So we're going to talk about the hydrological cycle today and the dynamics of water. So we're going to talk about precipitation like rain or fog drip. That's when moist air runs into vegetation and drips down to the ground. Precipitation is liquid water. Evaporation is what happens when water meets warmth. It evaporates back into the gas phase. And another important aspect is evapotranspiration. And this is the interaction of the plants on this planet, this blue and green planet, that pull water through their roots, right, into their vegetative parts and evaporate them from there back into the atmosphere. So the Hawaiian term is waipio, the arch. the bend, the curve, not the rainbow. You know the Hawaiian name for rainbow? A nui nui. But Waipio is the arch of water, and it's a lot like the hydrological cycle. So look here. We're looking at precipitation. Rainfall comes down, soaks into the soil, maybe moves through into the groundwater, maybe moves from there into a stream. There's more evaporation. In the middle of that is transpiration, evapotranspiration through plants, facilitated by plants, back into the atmosphere. So this is Waipio, the hydrological cycle. We talked, was it last time or the time before, about orographic rainfall? It was a couple of weeks ago, right? Orographic. The trade winds coming from which direction? Southwest? Like they're going to this later on this week? Those are odd winds. Most often the trade winds, the predominant winds in Hawaii, come from the northeast. And they run into the mountains of our higher islands. And they have traveled over an ocean, so they're moist, they're warm, and they hit our mountains, and what happens? There's condensation at the what level? On the quiz, the inversion level, right? So there's precipitation. They also catch on vegetation, and that causes fog, drip. When warm, moisture-laden air intersects vegetation, the vegetation is cooler, and that causes condensation to occur. Fog actually precipitates into liquid water. So here's that moist rising air from the trades, condensing water vapor. On the other side of the mountain, it's usually wetter or drier?
Dry.
Absolutely. So the trade winds in Hawaii are from the northeast. And do you know where the wettest place on Oahu is? I think it moves around a little bit, but most often it's up in this northeast section around Laie Kahuku. Up in the mountains, that's the wettest place on Oahu. We think that it's pretty wet in Manoa, right? But if you walk from Waikiki to the top of Manoa, you see a change in moisture, a change in the amount of water that's available. So there's about 120 inches of water that falls in the back of Manoa Valley each year. In Waikiki, 12. So 10 times the amount. And that's that orographic effect. So I'm going to talk in the next few minutes about, the next 45 minutes actually, about two connected hydrological systems. On the surface, like a stream or a river, and subsurface, which is a groundwater. There's a lot of fresh water, though, tied up in all of the bodies in this room, all of the plants surrounding this building, and in the atmosphere around us. So there's a lot of water tied up in biological and atmospheric systems that's not in the ground or in the atmosphere. Here's a schematic. It's really complicated. It takes a long time to digest. I'm still working on understanding how all of this works. But here's a diagram that has been prepared by hydrologists, people who study water, looking at Oahu's water sources. So water comes from basically precipitation. Once it hits the island, it might move around. I'll give you some numbers in a few minutes, but a lot of water evaporates both from the land and from the ocean. And that evaporation of water is in the form of gas, right, back into the atmosphere. Rain that falls can do a lot of different things. It can move downstream, percolate into the groundwater. On Oahu, I'll just point out in this slide a couple of tricky things. So if you were on the field trip, you learned about these dike formations. This is part of the volcanic evolution of our islands. You also have heard it previously in this class. So this is harder, less porous basalt. These dikes can actually hold water back. More in a minute. Something else that happens on older Hawaiian islands like Oahu, Kauai, further north, is limestone grows on the edges of our islands. Right? These are our coral reefs. This forms something called cap rock, and it actually holds water in our aquifers. More on that in a minute. In our island groundwater. It slows the flow of water off of our islands. So cap rock is very important. On the Big Island, it's so new that there's not a lot of coral reef limestone that's grown in the last 500,000 or so years. So when water falls on the Big Island, it slooshes either off as runoff or through the groundwater, and you can map it. This is an image provided by Dr. Craig Lynn here in SOAS. And these images, so here's the shoreline, and these images show the temperature of surface water and nutrient concentrations off of the Kona coast. So the water just comes through in lava tubes and groundwater. You can see it bubbling on the shoreline. Back in the day, ranchers, and I think they still can do this, ranchers could actually water their cattle on the shoreline of Kona in particular places where fresh water was bubbling up, and the cattle could get enough fresh water to replenish themselves. Lots of terms in this lecture. The one that you will see probably on your midterm is watershed. So what is this term? It's a drainage basin, really. So the rain falls at the top and it starts to come down. And we try to understand then where that water goes. And in doing that, we then talk about watershed. So we can talk about a small watershed. Here's the very top. This is on Kauai. Actually, this is Hanalei Bay, just as an example. So the rain is falling everywhere, or not. I live in Kaneohe, and I'll talk to a friend in Kailua, and it's not raining there. Or I'll talk to a friend on the other side of Kaneohe, and they say, it's pouring down rain here. And I said, it's not even raining here. It doesn't rain the same everywhere all the time. Rain is falling. Where does it go when it rains? Where does water go when it rains?
Down.
Down. Always down toward the ocean. Living on islands, we know where that water is going to end up eventually. And that's a big message from today. So we're talking about many different scales. We're talking about different topography. And we're talking about the area of land on which this water is falling. So this is a small watershed, but we can also talk about the larger watershed that eventually will enter a stream and enter Hanalei Bay. And I heard this quote many, many years ago, but from the time it takes for a drop of water to fall on the top of a mountain until it enters into the groundwater and is pumped up by the Board of Water Supply into a reservoir and into the pipes that enter your home, and you turn on a faucet and drink it, is about 25 years. Do you like the way the water tastes? It tastes pretty good, right? Have you ever been to like Oklahoma or other places where the water, when it comes out of the tap, is orange? Or it tastes like sulfur, smells like sulfur? Oahu has great water. The Hawaiian Islands have great water. And it's been filtered through 25 years of salt. So surface water, do we water ski a lot on Oahu? in Hawaii? Not so much, right? Not in fresh water. We don't have a lot of surface water. There are only 6 natural lakes in Hawaii, in the whole state, and they're small. And I don't know anybody who water skis on fresh water, actually in Hawaii. So these are our, we also have, in addition to the natural lakes, we have a number of reservoirs which have been constructed by dams, by the Board of Water Supply, or ranchers or farmers to hold back water. Here's an example of a natural small lake. This is on the north shore of, anybody recognize this?
Polu?
Oh, I see it. What's that?
Polu? Is this Polu on the Big Island?
No, it's not. This is Waipio. Waipio, Big Island. Is that the same place?
Up in Kohala
Yes.
on the Big Island? Yeah.
Yes. Close to. So when you go to the end of the road,
Like down the trail.
calling it Honolulu,
Polu.
not Waipio.
No. I don't know.
Okay, we should check back in. So you see the waterfall coming down, clouds in the atmosphere, waterfall coming down. There's a stream that winds through this valley, a small lake here. A muliwai actually exists behind the shoreline, and here's the shoreline. So underneath, beyond what we can see, is groundwater. Thank goodness. So there's a saturation in many areas of the spongy rock that underlies the surface of the islands. We call these aquifers. I bet this is going to be on the midterm as well. Underground layers of water-bearing rock or material. So an aquifer is not like an underground lake that we depend on, but it's water that's permeated into the soil and the rock that underlays us. Sometimes, I showed you the images of the dikes. There may be perched water high up in the mountains that's held up and impeded in its movement toward the ocean by these dikes. We call that perched water. And how do we get the water out of the ground to drink? We dig a well, and pump it out. So there are hydrologists, water engineers, who try to understand the elements of the water cycle very specifically. And why is this important to understand these elements? Because after oxygen, it's the second most important thing to our well-being, right? Both for drinking, but also for irrigation. So here are the most important elements. Measuring precipitation and fog drift that I mentioned earlier. Measuring and understanding evapotranspiration, the movement of water facilitated by plants. Measuring, this is hard to see, ocean discharge, either through streams or groundwater. And on the Big Island, groundwater just is unimpeded for the ocean. On Oahu and Kauai, there's cap rock around the island, limestone cap rock that slows its movement. And in the middle is this aquifer storage, water that's stored underground and available to use. Here's another kind of general illustration of the same idea. So these are those dikes. Here's some perched water up high on the mountain. Rainfall is coming down, more perched water. And of course, hydrologists, like everyone's specialty, have their terms. So I'm going to give you an equation in a minute, and it's going to freak you out. No, it's not. It's just an equation to talk about how these elements are related. Precipitation and groundwater moving into a watershed or an aquifer are the inputs. The outputs, think about it. evapotranspiration, stream or river discharge into the ocean, pumping water out into our homes and businesses, ocean discharge, which can be just plain runoff, and groundwater out, which might be a diversion through a ditch or a natural diversion into another watershed. So these terms are ways for us to try to understand the overall water budget, the hydrological cycle. Here's that scary equation. It's really not. So here's the thing that the many hydrologists are concerned about, is the change in water storage. How much water is available for the community to use that's stored in the aquifer. So this is precipitation, groundwater in, evapotranspiration, river discharge, pumping, groundwater out, and ocean, how do we put that? Ocean discharge. So if the system is in equilibrium, then precipitation and groundwater in are going to be equal to all of the other elements of the equation. That's in theory. I'm going to show you some other estimated numbers from the Board of Water Supply in just a minute. Here's this idea of the aquifer again. And I just wanted to emphasize that freshwater is, what do you think, heavier or lighter than saltwater?
Heavier.
It's lighter. Freshwater is lighter than saltwater. It doesn't have salt in it. It floats on top of saltwater. So we see an intrusion of saltwater. Freshwater floats on the top. So if we look at our coastal aquifer, what this looks like at the coast, here's what we call the water table. So here's the ground surface. Fresh water is stored in the aquifer. At sea level, there is a pressure back that holds the lighter fresh water, into the aquifer on the island. The density of fresh water is about 1/40th that of seawater. So you can see what floats on the top. And we call this a freshwater lens. For every foot of freshwater lens above sea level, there's 40 feet of freshwater below. I mentioned the higher level aquifer earlier, and this is water that's held up because of the geology of our islands, because of the differential density of the rock up above, usually due to dikes. Okay, just to refresh, YPO is the arch, the bend, the hydrological cycle. Precipitation, evapotranspiration, surface water, groundwater, and the aquifer. There are a number of ways to understand how water gets from the top of the mountain to the ocean. And these can be important, especially if you're a rancher or a farmer. And you might want to utilize that water. So we have overland flow. That's when it's raining so hard that the water just flows on the top of the soil or the asphalt and rushes right to the sea. We might have something that's called saturated overland flow. That means that the soil has already absorbed so much water that it can't absorb anymore. So again, the new precipitation is going to flow right to the sea. And then there's interflow between the ground surface and the water table below. interesting situation in Hawaii that we don't have a lot of slow, lazy rivers, but we have a number of streams. For example, think of Kaneohe. Think of the watershed around Kaneohe Bay, which is the largest embayment in the state. In that embayment, there are 9 major streams. So the water hits the top of the mountain and then is collected, seeking the quickest route to the ocean. And it depends on the topography of the area, right? And the water also creates its own trail through erosion. The small rivulets at the top run into each other and form a bigger body of stream water flowing downhill. These collect, and all of this is runoff, leading to the ocean. Hawaiian streams are called flashy because when it rains, sometimes it's just a little trickle, but sometimes it's a downpour. So we're trying to understand how much water is coming down. How do we do that? You just stand out there with a cup all day long on every mountaintop and measure the rainfall? No, we don't have the ability to do that. But we do have the ability to monitor stream flow. So there are gauges in most, probably all of the streams around the state. And you can see here, they're put in by the U.S. Geological Survey. So these gauges are monitored. So here's one on Wailuku, Maui. And you can see that on this particular day, wow, there was a big rainfall event, but it only lasted for half a day and then trickled back down the rest of the week. Same thing, there's a Wahiawa, Oahu, big rainfall event, and slows down. You might see another one. When is the wettest time usually in Hawaii? About now, yeah. January, February, a little bit of March. This is our rainy season. So these are the things I want you to remember. That the factors that define where the water flows are the surface geology, the topography of the island. The subsurface geology, are there dikes? Is it sandy? Is it forested? Oh, sorry, that's not subsurface geology. The movement of the water from the surface to the groundwater is called recharge. A little bit more later. There are natural and man-made sources and sinks, so we move water around how? I'll show you a picture in a minute. Through man-made tunnels, and also the proximity to the coast. And this is important in my little world because freshwater and coral reefs don't get along. So when there's a big rain event, often we're looking for mortality of coral reefs close to stream mouths. Corals don't grow by stream mouths, so, okay. You know we use water. You've had water today, right? Brush your teeth, had a drink of water, had some coffee. We've used water since the first humans arrived on these islands. Pre-Western contact, there was a big change during the plantation era, and I want to talk a little bit about what's going on. So, pre-contact hydrology. How was water used then? There was mostly native vegetation plus the canoe plants. There were extensive lo'i and awai systems. Lo'i are taro fields, and awai are the water systems that Polynesians, Hawaiians built to provide water to the taro systems. There were extensive cultivated fields, and you can see in this photo at Kohala, on the Big Island, there were terraces for agricultural purposes. There were many fish ponds, on the shorelines, and there were little to no pollutants in the streams. Polynesians, Hawaiians utilize their resources as best as they were best suited to be used. So on the windward side, on the windward Ahupua'a and stream valleys, you would expect more or less rain. Windward side, northeast trades, more wind, more rain, more water. So also more erosion in streams and stream flows, more lo'i, more wetland taro. This wet environment was very important in food production and harvesting. On leeward shores, which would be where on this island? One side, right? Groundwater was more important to people. Although they had access to upland springs and streams, there were more cultivated fields. Fish ponds were also important. And luauai, I showed you a picture a little while ago. Luauai were important for freshwater supply of home use. So here's a luauai on the leeward side of, actually Oahu, taken by Dr. Kinsey. In the last 150 to 200 years, there were a lot of changes. Deforestation, plantation building, drilling for water for human use, construction of these ditch systems, these are not awai, abandonment of the fish ponds, and loss of native agriculture and versions of native awai. Why were the fish ponds and mala and awai abandoned? Because there was a tremendous decline in the native Hawaiian population after Western arrival because of disease. You might have heard of Campbell Estates, Campbell Industrial Park. James Campbell was one of the early guys in the late 1800s. He figured out how to get water out of artesian wells. Those are wells close to the, water close to the surface. These were pumped for sugar plantations. But in like 20 years, they had been pumped so hard that salt water I mentioned earlier had been pulled up into the freshwater lands, and so now the wells are salty. So that's not good for agriculture, not good for sugar or pineapple. So by 1926, actually there was this water panic. Interesting idea, huh? So the artesian wells had been overpumped, and resource managers realized that they needed to take care of a limited water resource supply. There's different kinds of wells that have been dug, not just here, but around the world. So vertical wells in coastal and high elevations. These Maui type wells, as they're called, are slanted. There are tunnels into the dike areas, those perched high elevation water areas. Have any of you been to any of the water tunnels? The Board of Water Supply gives tours, and they are amazing. You walk for half a mile into a dark tunnel, and you might stand there. The last time I visited one was on the windward side, and they told us that, I can't remember the elevation, but they told us that the water that was coming out of the walls there, and you could hold a cup into it and collect some, was about 9 months old. So it was a place that humans like to go to gather water to celebrate the birth of a 9-month-old human baby. I don't like dark enclosed spaces, but it was a really good tour. But again, coastal wells get salty because of saltwater intrusion. If you pull the fresh water up too hard, the salt water that surrounds our shores will come into our aquifer and make a problem. Most of the main Hawaiian Islands have these extensive ditch systems that were dug in the late 1800s, through the mid 1900s for agriculture. And what were the primary agriculture? You think of Hawaii in the 1950s, and what do you think of? Sugarcane and pineapple, right? These were huge. They transformed the landscape of Hawaii completely on the main Hawaiian Islands between, again, late 1800s and up until the 1970s and 80s. So these ditches were dug through the mountains. And I want you to be sure to see this video. This is a homework video, The Hard Taro of Waihole. And you won't believe this story. So this is the story of ditch tunnels that were dug through the mountains from central Oahu to the windward side. Why? To get that water to irrigate the central plains that were mostly pineapple and sugar. These tunnels are about this high. So if you're a tall guy, it's kind of a struggle to get through there. But anyway, this is the story of the struggle of the Windward people who said, you stole our water, and we'd like to have it back. So please watch this video. It's an hour of your time. You can download it. Go to the syllabus, look for the link. So these ditch tunnels, the Waihole ditch tunnels, were built in 1910, and they're 12 miles long. Can you imagine being the person who has dynamited or pickaxed in 12 miles through the mountain to get water for the plantation owners, to get water from the windward side to the central plains of Oahu? All right, so things look a little bit differently on Oahu and the rest of Hawaii now than they did 200, 500, or 1,000 years ago. Think of the changes that have taken place. Polynesians built awai systems, they built lo'i, they built loko'ia. People need water to drink and to grow food. Then in the mid-1800s, for the next 150 or so years, this place was heavily developed and the vegetation was changed by plantations growing basically sugar and pineapple. But those plantations are now gone. Why? Where'd they go? How come they're not here anymore? Labor costs, is that what you said?
Yeah, well, it's maybe there's the buildings, but it's because of that.
What's that?
It's because of that, because it's cheaper labor.
Yeah. We can't afford to grow these crops in Hawaii anymore. Those ditch systems are mostly out of use. You can still see the remnants, but they're mostly out of use. But we still need a lot of water. There are about 0.9 million people who live just on Oahu, about 1.2 some million people who live in the state, and the other 7 million tourists who are here every year. People need to have drinking water. Our native forests are largely gone. We've heard about habitat destruction. That's kind of from Dr. Young. The vegetation that had evolved for millions of years has been largely disrupted. We have a lot of alien vegetation. And our coastal areas, I mean, think about Waikiki, think about Kona, think about Huntsville. Our coastal areas are heavily developed. Found this on the Board of Water Supply website, and I love the numbers. So how much does it rain every day on Oahu? Look at that number. The Board of Water Supply estimates that it rains about 21 billion gallons a day on Oahu. It's just a number to consider. Evaporation from the land can be about 50% of that. Recharge to the aquifer. So what do I mean by that? Percolation through the soil into the aquifer, maybe 10 to 50%, and runoff and or groundwater discharge. That's how water is moving toward the ocean. Streams, runoff, or groundwater discharge may also be another 10 to 50%. Humans apparently are using, as they estimate, about 407 million gallons a day. So we're not catching and drinking all of the water that falls on Oahu every day, by a long shot. And in the future, what do you want to think about? If you are a water manager, what are the most important things on your mind? Probably the population in Hawaii will continue to grow. So we will need more water for drinking, cleaning, flushing. As I said, sugar and pineapple are gone. But we're starting to see new agriculture. If you drive to the North Shore, H2, you start to see that new agricultural ventures are beginning. We'll see where that leads. It's labor intensive, but there are boutique crops that bring in higher income perhaps, and that might allow diversified agriculture to develop and expand on Oahu. I mentioned we do have increased domestic use. So do we have enough as people? And how about the biota? Is there enough to support the native plants and animals that live in the state? Questions?